I want to give you some guidance here with the laboratory skills lab simulation. So this is the data sheet that you can download in the same folder, and you need to have this so that you can write down the results as you get them from the experiment. So as I've done in the past, I'm going to go ahead and open the lab here. Now you'll notice it opens in another tab, and I'm just going to drag it over here, and you can see that now I can enlarge that window. Okay, just make sure it doesn't go too far over there. There we go. I could probably drag it a bit more here so it doesn't cover up any of the writing I've got here for my procedure. So go in, start the lab. So we'll start with experiment 1, measure the volume of a liquid. Take a 250 ml beaker. There's a 400 ml, that's a 250, so stick 250 here. And a 50 ml graduated cylinder from the container shelf. So the graduated cylinder, I don't see it here, so I click over. There he is, 50 ml graduated cylinder. I'll stick that on here like this. And it says here to take water from the materials shelf, add about 40 to 50 ml into the beaker. So that's what I'm going to do. I'm just going to add, I'll add in 43. Whoops, too much, 43. So I've got 43 mils here in this graduated cylinder. But now I'm being asked to transfer it into the beaker. To do that, what I do is I just roll it over the beaker like this, and it gives me an option. I can either dispense a portion of it, or I can pour it all in. So that's what I'll do, I'll pour it all in. That's what directions ask me to do. Okay, so now what I'm going to do, and this is going to be fairly important for me, is to zoom in on the beaker. And remember, I can use a combination of these plus and minus magnifying glasses here, and these arrows here to center it so that I can look at this a bit more closely. So that's about as far as I can zoom in. But I'm looking at this. I know I've added 43 mils because that's how much I put in. But I'm looking at this beaker and I really can't tell exactly how much I've put in here. I know it's close to 50. I might even be able to say it's between 25 and 50 because this would be 25, that'd be 50, that'd be 75, that'd be 100. I definitely know that. I know it's between 25 and 50. I see it's fairly close to 50, but I really can't tell exactly what that is. So all I can do is estimate it, and I might estimate it to be 40 mils. I know I put 43 in there, I know I put 43 in there, but I can't tell that by looking at the beaker, and that's the entire point. The beaker is not a very good measuring device if I want an exact measurement of water that's been put into that beaker. That's because these graduations are too far apart to get an accurate reading. So I would be inclined to write 40 for that, even though I know I put 43 in there. You can't look at this and tell me that you can see that you've got 43 mils there, and that's the entire point of what I'm talking about. Alright, so I'm going to come back out of there a bit, and I'll go on to the next step. It says to take an Erlenmeyer flask. Now let's see. I'll get an Erlenmeyer flask. I'll get a 150 ml here, and I will pour again all of the contents of the beaker into the Erlenmeyer flask. I'll zoom in again on that, and I'll see what's going on with the volume there as well. Oops. I'll just use the arrows here to get it more centered rather than move it around. It's probably a better idea. Good idea for you too, I think. Alright, so looking at that, it's a little bit hard to see, but again, you can see that it's kind of close to 50, but you really can't tell. So I would be inclined to say 40 for that as well. So now we've got to move the Erlenmeyer flask onto the graduated cylinder and pour it all into the graduated cylinder, and then we can get get an estimate of the volume in that container as well. Alright, so let's do that. I'm going to zoom out here. I'll take the Erlenmeyer flask, I'll pour it into the graduated cylinder, pour all. And now what I'm going to do is I'll move these, I'll actually move them into the sink to clean them up. And I'll move this over, we don't need those anymore. And I will again use the arrows so that I can look at this. Now I can actually make a much more accurate estimate of the amount of material I have in this graduated cylinder as compared to the beaker and the Erlenmeyer flask. So I'm looking at it and I can see I've got 40 here and 50 here, so I'm definitely sure of the first digit. I know it's 40 something. I wasn't even sure of that with the beaker and the Erlenmeyer flask, to be honest. I just knew it was close to the 50 line in those cases. But here it's got 1, 2, 3, 4, 5, so that'd be 45 right there. 6, 7, 8, 9, that'd be 50. So I know what each of these is. Each of these is 1 mil. And I go 1, 2, 3, so that's 43. I know that's at the 43 line. But there's something else that we need to talk about here, and that's significant figures. And what we know is that we can actually measure in between each of these graduations. So I know that if this was halfway in between this graduation, I'd say it was 43.5. If it was halfway between this one and this one, I'd say it was 43.5. That means that if it's on the line, I can't just write 43. What I've got to do is write 43.0 to indicate that it's on the line. So that's the way I handle the measurements with these graduated cylinders. If it's on the line, I write 0.0, and if it's directly in between the lines, I write 0.5. In any case, I need one decimal place after one place after the decimal in order to write my measurement down. And that's all due to significant figures. So this is experiment 2. We're measuring the mass of a liquid. So we're told to take a balance and put on the bench. Then we've got a 250 ml beaker, which we'll find here, and it asks us to weigh that. Now here it doesn't say to record, oh no, it does say to record the mass of the beaker. So that's where you'll go to do that here, mass of empty beaker. Now when you're writing that mass down, make sure you include all of the figures that you see here, because that's the precision of the measurement. If you remember when we did the graduated cylinder earlier, we talked about how it was important that if something was directly on the line, make it 43.0 milliliters. It's the same thing here. It's almost like this is on a line here, and you need to write 110.000 grams, because that is the precision of that specific measurement. If it was 0.001, you'd have no problem writing 0.001. If it's 0.000, you should do the same thing. The unit here is grams, because that's what it says on the balance. That's what you should write down as well. So I'm actually going to go ahead and do that here. And write down 110.000 G. And that's all you have to do. Now what it says here to do is zero it. So I zero it, and you can see it goes down to 0. And if I take that beaker off, here's what you'll notice. It goes down to minus 110.000 grams. So now anything we add to this beaker will be taken into account when we put it on the balance, but the beaker now won't be taken into account. That's all you'll see is the mass of whatever we put in the beaker. So I'm going to go ahead and add in the entire contents of this graduated cylinder here. And then when I put it onto this balance, that will just give me the mass of what's in the beaker, and that's it. So I'm going to go ahead and let you do that and write that down, and that will also go on your data sheet as well. Mass of beaker with water after the balance was tared or zeroed. Tared and zeroed mean the same thing. Alright, so we're going to now look at experiment 3, measure the mass of solids. So it says to find a 150 ml Erlenmeyer flask, which I'll go ahead and put on the balance. And what we're going to do is zero the balance here. And in this case, I'm actually going to take it off the balance so you can see it goes to minus 94.000 grams. We need to go around here and find the salt sample, which actually isn't any of these. I think you'll find it over here. Mixture A, mixture B, mixture C. And there's a salt sample there. So that's what you're looking for. Now this has already been pre-weighed out or pre-put in here. It's going to be a certain mass. So we're going to stick it in here. And you'll notice that when I stick it in here, a little amount appears on the bottom. I'll zoom in a bit here. You can actually see it there on the bottom. So don't, even though you might not see anything in there initially, if you look closely you'll see that it is something in there. And then if you do try and put some more in, it will tell you that only 1 unit is allowed. So I'll go ahead and do that and you can see this. See, the container must only have 1 unit, so that means you've already got stuff in there. So it stops you from kind of putting 2 in. So then you can put it on the balance and you can get a mass. Now that mass is the mass of just the salt without the Erlenmeyer flask. Now you're going to do the same thing with these other samples here, the baking soda sample and the aluminum sample as well. So what you can do is, in order to complete that part of the experiment, you can stick that in the waste container like that, and then you can put this into the sink. And then what I would do, I'd zero it, and I'd grab another clean Erlenmeyer flask and complete the experiment again with those other 2 samples and just do exactly what we did for the first one with those 2.